Welcome to AC Test Lab. I'm Conrad.
And I'm Barry.
And today we're going to look at exactly just how important an unloader valve really is.
Well, the way an unloader valve normally works is it unloads any excess pressure back to the tank that's supplying the pump. You see, the inlet of the pump is here. A hose tail is placed on it. And it goes through a pipe which sucks water from a container, like a water tank in your van. Could be a wheelie bin, could be a small tub or any receptacle. As long as the water that's been supplied can keep up with the water that's been used by the pump. So the water is sucked in through the pump, it's expelled through the unloader valve on this bit here, this end. It goes through your hose, through your trigger, down to the lance and out through the nozzle, which creates the pressure. Now the unloader valve will be set at a certain pressure for whatever pressure you're using at the time. Any excess pressure will be diverted along this pipe, through this hose tail, down a pipe and back into the tank. On cheaper models, it will be diverted back into the bottom of the pump. This is frowned upon because when you let go of the trigger, it just circulates around the pump. It gets very hot very quickly, damages the ceramics, damages the seals. Literally 20-30 seconds left on its own and it will need a complete reseal. When you let go of the trigger of the gun, any pressurized water that goes out of the end of this through the hose to the gun has been restricted by the trigger. So then it is all diverted through this hose tail back into the tank, as it's nowhere else to go. Now if for some reason this jams up or it's set too tight, doesn't unload through this tube here, when you let go of the trigger, the pressure in the pump has nowhere to go except to build up in the pump, and this happens very quickly. It's almost instantaneous and it can end up in catastrophic results. Normally it will blow a cap off the top or blow a cap off the front. Sometimes it blows the end caps off. Sometimes it can blow the pump head off, and sometimes it can destroy the pump. In usual cases, the pump is set to match the engine at the pressure and the flow that the pump is normally run at. So if it does pressure up, the engine will die down because it can't cope with the excess torque needed to run the excess pressure. So the engine will die down and probably cut out. If you're using an engine that has more torque and produces more kilowatt than the pump is being used at the time, which means it's got excess torque for the pump, it can then pressure the pump up to dangerous pressures. So if the unloader valve fails, the pump will pressure up to destruction and the engine won't fail. So to demonstrate this, rather than put it on say, a GX390 engine, quite capable of running it at the pressure and flow that it's supposed to run at, we decided to run it on a 11LD 6623 Lombardini engine, 3-cylinder, around 35 horsepower, which has enough horsepower to run this pump around 600-700 bar. So it's easy enough power to demonstrate what happens to the pump when the unloader valve sticks on, or when the unloader valve doesn't unload back to the tank.
Now we need to stress, you don't try this at home. It's an incredibly dangerous experiment and we're very trained idiots. We do this so you don't have to. So as you can see, this is the pump that is connected to the engine. This pump can do 30 litres a minute at 250 bar. This is the pump that we are going to use. It's a lot smaller than this one. Maximum rating is 14 litres a minute at 210 bar. The engine is massively overpowered for this kind of unit, so this should test it to destruction.
We'll clad it where we can in aluminium to protect it from any flying debris. Well, to protect us from any flying debris anyway. Let's do this. We've attached the pressure gauge to it. We've replaced the unloader valve with a steam valve, which is basically a little needle valve that lets a certain amount of water through until you turn the needle valve all the way, and then the pressure can't go anywhere and it just builds up and builds up until it obliterates the pump. We've set it up so the needle valve is remotely operated from behind this shield. There's also an emergency stop button on it as well. So if there's anything disastrous happens, we can just knock it off. And as soon as it blows or something blows off it, then we can just stop the engine.